Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is smart telescopes. And here to talk about them are my two guests. First, here in the studio, Sean Pickard. Sean, good to have you back on the show, sir.
Yeah, it's nice to be back. It's been a couple months since I've been here.
Yes, it has.
Covering a range of topics every time I'm on here.
And our other guest comes to us from metropolitan Toronto via Zoom, Steve Mallia. Steve, also welcome back to the show.
Thank you for having me. I'm glad to be here. It's been, I think it's been a couple of years since I was last a guest on the show.
Yes, it is. So we've got you guys together here so that we can talk about smart telescopes. Now, Sean, talk about what imaging was like back in the old days.
Back in the old days. So we're going to jump into our time machine, whatever time machine you have in your backyard. We're going to go back to January 26th, 1949. And we're going to go join Edwin Hubble sitting up in the prime focus cage of the Hale telescope on Mount Palomar. That's a 200-inch telescope. For his first light, he sat there all night tweaking the little knobs, keeping the star in between crosshairs, and he was able to get the Hubble Variable Nebula. But the issue is with the Hubble Variable Nebula or sitting up in prime focus, is that he has to sit there and the whole night, and if he falls asleep, night's ruined. If a light gets turned on, night's ruined. So it's a lot of meticulous working back and forth, and you need somebody to show up to rotate the dome every 15 minutes. And you need mountains of money to do that. Quite literally, it is Mount Palomar.
Well, there you go.
And that was back in 49, and now you're coming up into the 2010s, and instead of a mountain of money, you need some suitcases, and you can get an observatory in your own backyard. This is from my observatory in my backyard. Doesn't look like that now. I've added some new equipment in there, courtesy of Steve, of course, and move things around, but that's definitely not mountain money. I just have
That's your suitcase.
That's my suitcases of money in there. And from the telescope that's on the left, on the all-white mount and white telescope, I captured the Hubble Variable Nebula as well. And so we can compare what Hale did, what the Hale telescope did over one night of capturing, and that was a single frame of capturing. Mine was, I think, 30 hours total of integration. So that's like 5-minute frames. And so if something messes up, I just throw out a 5-minute frame. The whole night's not ruined.
Well, because when Hubble did it, he had wet film.
He had wet film. He was sitting there imaging in that one frame all night. And I was sleeping during all of mine. I wasn't sitting there at the knobs out in the cold in January, sitting out there fiddling the knobs, keeping it going in the center. It was like I was asleep. I could wake up whenever I want. I didn't need to stay up all night.
Interesting. Yeah, made it a lot easier.
For sure, for sure. And now we've gone from that of needing suitcases of money to maybe a month or two where you put some money away, and then you can get some of these telescopes, these little smart telescopes like the C-Star S30, the S50, which I have sitting here. These are both from ZWO, but you also have Celestron has their Origin, which is a more telescopy telescope. It's what's called a RASA, but it looks like a telescope. Or you have the Stellaris or the Dwarf 3. There's a bunch of them out there, and they all work very similar to each other, where you have a tripod, you have a telescope that has a battery and the brains all in it, and you have an app on your phone for controlling it all.
Okay. Well, Steve, from your vantage point, you're both a retailer and a manufacturer. How do you see this latest digital imaging equipment?
I think it's fantastic. Smart telescopes have now opened up the arena of astrophotography to a whole new um, group of people that wouldn't have thought, I'm not going to be an astrophotographer. I don't want to spend the money. I don't know what I'm doing. I'm not techie enough. I don't want to be carrying all this equipment. Now we have this beautiful small scope, right? Like this ZWO S30, right, that does such an amazing job. And I think it's probably one of the most important pieces of equipment right now for amateur astronomy in general, because now we are opening up the night sky to so many more people, right? Especially with the type of light pollution that we see in a city, even on the outskirts of a city like I am. I'm in a bit of a rural area, but I still have a lot of city lights around me. Um, People can now, see what's there, right? Easily, or they weren't able to do that before. It from the ZWO offerings to the Dwarf Lab 3 to the real big one from Celestron, right? It they all have their capabilities and their function, but people can get into this very, very inexpensively and get fantastic results with a little bit of effort.
And Steve, you're an astro imager too. I know how I felt when they were first came out, and I was like, these are dumb. They're gimmicky. Who's gonna like them? But then as soon as I started, I saw someone was streaming the annular eclipse with the S30 or the S50, and I was like, oh, I'm gonna check this out. And I've completely flipped. How about you?
Yeah, I know. I when I first saw it, I wasn't quite sure what to make of it. And really, th- they're using a technique that's been around for a while. When you think about it, like if we look back at um, some of the offerings that existed 10 years ago, even longer, 15 years ago, maybe not that long, but around that time. Look at some of the cameras that were existed at the time, like the Mallincam cameras, where they did that live stacking built into the camera. Now there was still a lot of work that you had to do, and you had to carry a lot of equipment to get it to work. But the technique of stacking, live stacking, right, or EAA, electronically assisted astronomy, has been around for a little while. Um, what I remember, say about 10 years ago, 2015, right now we were seeing programs like SharpCap and some other pieces of software that were doing live stacking as well. But you still had a lot of equipment. You had your laptop, you'd have to run out and power and so on. So now that we have a device that has good optics in it, remember the C stars have a triplet refractor built into it. That's a true Apo style refractor, just a very small focal length. But when coupled with the size of sensor that it has, right, the results are there, and um, I know I kind of went on a bit of a tangent, but to answer your question, right, did I think it was gimmicky? Not so much, right? Was I curious to see what it was going to look like when we got that final result? Very much so. Um, was I even more delighted when I found out you can take the information out and you can then manipulate it separately to get an even better image? Absolutely.
So there are a number of different manufacturers out there. If you gentlemen could perhaps name a couple of them to familiarize our viewers.
There's the Vionis. There's Dwarf Lab, ZWO, Celestron. There's another one I can't think of their name.
Yeah, there's a couple more. There's a company called Beaver Labs that does something similar. I've seen a couple of other ones that just recently come onto the market that I don't fully recall their names, but it's starting to become more and more prevalent in the amateur astronomy arena to start seeing smart telescopes, and I think we'll start to see more manufacturers do it. Um, you mentioned Vionis. There's also Unistellar, right?
That was the other one.
Unistellar is quite interesting because they do a more of a collaboration style with their scope. So the data that's collected can be uploaded to their servers, and it becomes part of a larger study, right? So it becomes a database of information that researchers can go and access and look at data. So if they wanted to see if there were images taken from a few months ago, a year ago of a particular object, and they can maybe do a timeline. That information is there, and that's part of the unistellar setup.
That sounds very interesting, a very collaborative effort on the part of the imaging community using this particular brand.
Yeah.
So any other comments about these particular scopes before we head to break?
No. I know when we get back, we'll show some images that they had. I know Steve's got a new toy that is very hard to get his hands on. Even as a retailer, he doesn't have one in his hands yet, and I'm very excited about too.
So that's something that we'll definitely delve into in our second segment. So this is a great place. If you have a question, please send us an email. The address is down there at the bottom of your screen. And coming up next with Term of the Month is Stephen.
Thanks, Don. The term of the month is I process. Elements up to iron are made in stars using fusion. There's also the S process and the R process. S for slow, R for rapid. Neutrons, when a neutron is captured by a heavy element, it eventually may decay and turn into a proton. The atom then becomes the next heavier element. At tens of hundreds of billions of neutrons per cubic centimeter, the S process takes place taking thousands of years. Elements up to bismuth, which is atomic number 83, can be formed. At 10 billion times higher density, the R process produces heavier elements taking under a second. That would be the end of it, but astronomers found early metal-poor stars that are carbon-rich with unlikely element ratios. This suggests that the I process, I for intermediate, is active. The I process was proposed in 1977 and mostly forgotten. The idea couldn't be examined experimentally or with modeling. Today's sensitive astronomy and computer modeling changed that. There's a big collaboration between people doing nuclear physics, modeling, experimental physics, and astrophysics. Nuclear modeling is complicated by interconnected reactions. Modelers ask nuclear physicists to measure reactions to constrained processes. Different facilities can do different experiments due to having different instruments. The collaboration is still expanding. The current open question, or a current open question, is if the I process ends like the S process, or if it can proceed to the actinides, elements 89 to 102. In the next 5 to 10 years, the I process may become well understood. And that's Term of the Month, I process. Back to you, Don.
Thanks, Stephen. We're back with our guests talking about the new smart telescopes. With me here in the studio is Sean Pickard. Good to have you back for segment 2 here, Sean.
Segment 2.
And also via Zoom, we have Steve Mallia. So, Sean, you've been working with some of this equipment. Can you give us some observations about it? Pardon the pun, by the way.
Yes, I have been playing with them for quite a while since I decided to dabble with them, and they've been a lot of fun to use. I've imaged M42 with this one back here, the S50, and they'd come out with something called mosaic mode. So in mosaic mode, I can take its normal framing, which is on the left side, and you can say, maybe my object that I want to image is bigger than that. So you can put it into mosaic mode, and you get kind of just like you were zooming in a picture on your phone, and you adjust the box on it, and then it will start taking a picture, and it'll slowly fill in the whole rest of the picture. And the scope just moves around and takes new pictures and moves around a little bit.
Oh, so you don't have to do that manually?
Don't have to do anything.
Oh, okay.
And it just slowly fills it all in. But then, so that was really cool when they had added that in, since now you're not limited to, well, my object is just too big to fit in, it's not going to work, well, I have to pick a new one. Andromeda is famous for doing that,
Yeah.
and just being too big, or
the
not
Veil Nebula, maybe?
Veil,
Yeah.
oh yeah, for sure the Veil. But then you run into, as Steve brought up in the first segment, of integration time, and I kind of touched on it too. So I have an image of M45, the Pleiades, famous, the
Sure.
Seven Sisters. So you have on the left side, you have 4 minutes. You can kind of see the little wispy in there of the dust, but then 96 minutes of that live stacking, you can definitely begin to see that information
That
more.
nebulosity really starts to show
It does.
up.
It starts showing. You start cutting through that light pollution. And Steve, being near Toronto, could maybe not in 96 minutes, but would be able to get something like this
Okay.
too. And you're not necessarily limited to deep sky objects either. You can do solar system work. Both the ZWOs, I think the Dwarf 3 comes with it, or you can get solar filters for a lot of the other smart telescopes, so you can take images of the sun or the moon or even the planets. You can tell that's Jupiter on there. It's not the best picture, but you can look at it and you go, I see the bands. It's Jupiter.
Sure. Yes, you can. So that's been your experience using these particular equipment,
Yep.
and sounds like you're very happy with the results.
I do really like it, and especially as Steve touched on, is it's introducing people. You're not going to Kmart or Walmart now
Yeah.
and getting their off-the-shelf telescope that can't even focus on the moon. You're spending a little more than that, not too much more, but you're going and you can give that to your 5-year-old even, and you say, here, go find something, go play around, and they can go look at an object and get interested and not get discouraged because they can't see the moon.
Well, and I also understand, Steve, that there's a piece of equipment that you're excited about.
Yeah, yeah, absolutely, and I'd love to talk about it. But I wanted to add to what Sean was saying too about what these scopes can do. We've had these comets coming by recently, and I went out to a darker part of a darker area, and I had a nice horizon where I was, and I actually took my S30 and I put it on the roof of my car, and the roof of my car is glass, so I was able to see it, but that's not fully necessary. And sitting inside the warmth of my car, because being in Canada, it's not warm right now. I was able to sit there and control my S30 from my phone, sitting in the warmth of my car and watching it doing its thing, and it found that comet first time, and I was able to start imaging the comet. So that's another really nice factor with these smart telescopes, because the software being updated on a regular basis and new objects being put in there to be able to find a comet, or even to, if you had to program it in on your own, which you can, I think this adds to its functionality as to what they offer, right? But yeah, there is something I really want to talk about. I'm really, really excited. I actually had the pleasure of using this when it was in prototype, a little over a year ago at our star party, Starfest. Evans from Pegasus Astro came to do some testing with the Smart Eye. I had seen the Smart Eye before in a demo mode, right, where they were just flashing pictures that they had taken with it into the eyepiece. But I actually got to see it in action and use it, and then a couple of other times after that. But I'm gonna share my screen so that we can you get an idea what I'm talking about. And there we go. So this is the Pegasus Smart Eye, and this is the world's first smart eyepiece. It has a camera built into it. It's no different from some of the cameras that we would be using with our deep space imaging rig. Right, it uses an IMX 533, and it has an eyepiece portion of it that you actually look through. Um, and that, from what I'm told, is it's a very high resolution screen. It's a 4K screen. It has a tech cooler built into it. It can broadcast the image to a tablet. You can use it as a camera as well. But what this essentially does is, using Sky Safari, because it's powered through Sky Safari, you can now control your scope through Sky Safari and then have the image being displayed in the eyepiece, and it's a fantastic, fantastic piece of equipment. I'll show you. They have a really nice example here. So your night sky is going to look something like this initially, where it's just stars, right? But it takes a picture and it takes another picture and it does that integration as we would have with other smart telescopes. And then we start to get a view that looks like this. And and I looked at the Trifid Nebula as we see here, and that is exactly what you see. You see that exact view. At Starfest last year with the prototype, I got to a bit of an argument with Evans from Pegasus because he felt I was taking up too much time at his telescope looking at the Lagoon Nebula. It was absolutely beautiful. It looked like it was three-dimensional. It was in full color, and it was a live image. Um, Looking at M51, the M51 we see in pictures with the blues and the golds, right? In that wispiness, it was all there. So it's quite impressive on what the smart eye can do and how it can take your regular equipment that you have that you've invested into, and then you can make it a smart scope by adding that integration time built into it right at the creating an eyepiece that will let you see things that you hadn't seen before visually.
That sounds like really like an amazing piece of equipment. So I'm sure you guys can't wait till it finally hits the market.
I'm definitely excited. About how long did it take to get to something about that point of that image you showed?
That image, okay, so I remember looking at the lagoon, um, and I'd say about between 30 seconds and a minute. Like you could tell, like there was one frame came in, it was monochrome. Then there was another frame that came in, added some more detail, it was still monochrome. By about the fourth frame, it sounded like this, like someone snapped their fingers and just popped, and there it was in color. And the more that you looked at it, the more detail came out, the more richness and depth in that image.
And the nice thing with the Smart Eye is it's not tied to like the S50 or the S30. You could take it to your buddy's got a 14-inch, or you know someone who's got a 26-inch Dob, or you're visiting PlaneWave and you can use their 1 meter telescope, and you can just slide in your Smart Eye on their scope and use it with that.
Absolutely. The one thing to keep in mind is you mentioned about a Dob. As long as that Dob has tracking capabilities, you're fine, right? This
Yeah,
can't be used in a stationary scope. It just because it has to be able to stack and take those images.
Yeah.
Well, Sean, in the couple of minutes that we have left, suppose somebody's interested in this, but they're not an astronomer.
True. As I had said earlier, hand it to your 5-year-old, which I have almost a 5-year-old now, and he likes messing around. I'll hand him my phone, and there's this nice feature I know the ZWO app has it, the Dwarf Lab I look into, they had it, and it's called Tonight's Best. So I have an image here we'll put up, and but wait, I'm not an astronomer. I don't know what's up there. Or even you've just decided, hey, let me go look at this thing. Let's go see what's up. What can I look at? So the image I have, it's from when I took it back in September. And on the left side is all the different objects that you could see in that night would be a good object to go look at. So you can look through it. You can click one. So I selected M31. So you get a nice pretty picture of what M31 might look like, a blurb about some information about it, the altitude chart, so then you could look at it and say, okay, well, it rises in this direction, it's in the northeast, and it's here right now. So if you have, general compass directions and where 90 degrees is on a compass, you could kind of figure out. Then, of course, it gives you the more technical stuff of its right ascension, declination, altitude, azimuth, which you don't really need to know that. You can hit that red button. It just says locate target position. The telescope will spin. It'll start taking pictures. Go find it. And if it doesn't see anything, then you must be looking at a house or a tree or something like that. Maybe try a little bit later. What is really nice with these two is I've done the tests. I've had friends that do the test where you get the smart telescope in a box, and you wait till the nighttime, or even do it during the day if it's clear out. And how fast you can get the box open, get the app downloaded, installed, firmware updated, and being on a target. I did it with my S30, and it was 20 minutes. I was on the sun.
Amazing.
So it's just not, I don't need to know how things work and plug different cables in. It was just screw a tripod on, press the power button.
Perfect. Perfect. Well, I think our viewers are going to be very excited. Perhaps a few of these will find their way underneath the Christmas tree. Wouldn't be surprised. I want to thank both of my guests, Sean Pickard and Steve Mallia, for being on the show tonight. Please visit our club website, address down there at the bottom of your screen. And coming up next with What's Up in the Night Sky is Stephen.
Thanks, Don. What's up in the night sky for December 2025? The sun goes from Ophiuchus to Sagittarius this month. Winter solstice is on the 21st, so the days changed their lengths the slowest this month. Venus and Mercury are near the sun this month. The full moon is on the 4th. It's a supermoon. On the 3rd, on the 11th, we have the third quarter. On the 19th, new moon, and then on the 27th, we have a first quarter. Shown on the 1st of December at sunrise is Mercury and Venus. Mercury goes from Libra to Sagittarius and rises from an hour and a half to half an hour before sunrise. Max western elongation, which is probably your best day to see it, is on the 7th. Venus also goes from Libra to Sagittarius over the month and rises 45 minutes at the beginning of the month to sunrise at the end of the month. Then we have Mars and Saturn. Mars goes from Ophiuchus to Sagittarius. It's shown here on the 1st of the month. And it sets 30 minutes after sunset to 20 minutes after sunset over the month. We'll get to Saturn in the next slide with Jupiter, Uranus, Neptune, and Saturn. And this is also shown on the 1st, but 3 hours after sunset. Jupiter is in Gemini and rises 3 hours after sunset to an hour. Saturn is in Aquarius and sets 8 hours after sunset to 6 hours after sunset. Uranus is in Taurus and sets an hour before sunrise to 3 hours before sunrise. And then finally, Neptune is in Pisces and sets 5 hours before sunrise to 7 hours before sunrise. The Geminid meteors peak December 13th to 14th, start at 9 p.m. The third quarter moon rises late, so it's best, it'll be a little bit better earlier. Dress warm and keep your eyes open to a large chunk of the sky. And that's What's Up in the Night Sky for December 2025.